In this video, we are going to look at an introduction to organic chemistry. Now, when we talk about organic substances, we're talking about those substances that are obtained from living organisms, that is, vegetables and animals. Okay, now organic chemistry is the chemistry of carbon compounds. When we talk about carbon compounds, we're not talking about chemistry of oxides or carbonates or bicarbonates, no. So for the scope of this video, we're referring to carbon's ability, the strong characteristic that it has to form a strong chemical bond with other elements and also itself. Carbon's ability to form a strong chemical bond with itself is known as catenation. So what it means is that carbon can form, like, to itself, can get to 10, 11, 500, 300, 1000, and hundreds of thousands as the case may be. So these long chains is what results to the long chains or the ring. So organic chemistry is very, very important because it is through organic chemistry we get things like dyes, we get drugs, we get inks, we get paints, plastics, gasoline, rubbers, that's rubber tires, etc. A lot of things we can get from organic chemistry. So we look at classification of organic compounds. We need to understand that in many organic compounds, carbon is bonded to other atoms like nitrogen, sulfur, hydrogen, bromine, and so on. While in others, carbon is bonded to fellow carbon, either by single, double, or triple bonds. There are also some compounds where they are bonded to each other in the form of rings. So we can use what we call functional groups to really help us form a basis or criteria for naming these organic compounds in a systematic manner. It is the functional group that is responsible for the characteristic properties of the different classes of organic compound. So the first class we have is what we call aliphatic compounds. Now when you see this, they are just open chain, or what we call acyclic. A means absence of cycle, so it is open chain compounds. The second one we have is alicyclic. Alicyclic compounds, they are actually closed chains. They are closed chains. They are carbocyclic or ring compounds. For example, on this is that for the first one, an example is methane or ethane and so on. For this, it starts from propane, which if you want to draw it, it is closed. Every junction is carbon. Every junction is carbon. We also have butane. Every junction is carbon, 4 carbon atoms, butane. Another major one we have is aromatic. Now when we say aromatic, we're saying they are ring form compounds. They contain at least benzene ring. For example, this is the benzene. This is the benzene. So this is benzene. So we also have the phenol, and so on. We also have naphthalene. We have the naphthalene. The next one we have is the heterocyclic compounds. Once we hear hetero means different. Here they are cyclic or they are ring compounds, but it's just that they contain other elements apart from carbon in that same ring. An example is the thiophene. That's an example. Or the furan. Oxygen. Then we have double bond here. These are examples of heterocyclic compounds. So when we classify organic compounds based on the functional groups that they have, we're looking at, let's look at, this is alkanes. The alkanes, they have the general formula of CnH2n plus 2. So the way that you see them appear, they are single bonds. How we can use this formula, if we have something like methane, we can also have something, if we have C, it means N is 1. So N is the number of C's that we have. So if we have only one in C, H is 2. 2 times 1, 2, plus 2, 4. So H will be 4. Another example is if we have C2, C is 2, so N is 2. H times 2 times N, so 2 now, N is 2. 2 times 2, 4. 4 plus 2, 6. So H is going to be 6, and that is ethane. So for the sake of time, let me write out the rest and their functional groups. So these are the classes. We have alkanes. This is their general formula. This is how they are represented. We have alkenes. This is the general formula. This is how they are represented. Double bond is their characteristic. Alkenes, double bond. We have alkynes, triple bond. This is their general formula. We have haloalkanes. This is their general formula. When alkanes are bonded with halogens, we use X to denote halogens. We have alcohols, we have ethers, we have aldehydes, we have ketones, we have carboxylic acids, amines, esters, and so on. Now, before we can actually investigate completely the properties and structures of organic compounds, we need to make sure that the compound is pure. So we have some methods of purification, which include number 1, recrystallization from a suitable solvent. Number 2 is distillation at atmospheric pressure or under reduced pressure or under increased pressure. Number 3 is steam distillation. Number 4 is sublimation. Number 5 is chromatography. Number 6 is zone melting. So we can use this to purify some of these things. Please do well to subscribe to my channel if you haven't. Thank you.